So this week it's OCR GCSE Maths, June 2017, and it's paper 6, and we're allowed to use a calculator. Okay. Question 1. The table shows the populations of the 4 countries of the UK in 2012. All values are given correct to 3 sig fig. England, Wales, Scotland, Ireland. Write the population of England as an ordinary number. So that is 5. And then we want 7 powers of 10. So 2 of them are going to be taken up there. So we need another 5 zeros. Okay, so it's 1, 2, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've done one too many there. There we go. Work out the total population of Wales, Scotland and Northern Ireland. Give your answer in standard form. So we could write out the numbers in full and add them up. But I'm actually going to use a calculator for speed because we're allowed to do that. So on my calculator I'm going to type in Wales, Scotland, Northern Ireland. So these 3 figures. So I'm typing 3.07 and I'm using the times 10 to the power of, and I put 6 plus 5.31 times 10 to the power of 6 plus 1.82 times 10 to the power of 6. And it says give your answer in standard form. Well, the answer on the calculator is 102 and 5 zeros. So in standard form, that's 1.02 times 10 to the power 7. Okay. Just put the decimal place there. 1, 2, 3, 4, 5, 6, 7. Total population of the UK is predicted to reach 73.3 million in 2037. Calculate the predicted percentage increase in the UK population from 12 to 37. Give your answer to 2 sig fig. Okay, so 2012, the total is it's going to be 5.35 times 10 to the 7 plus your answer from part B. Okay, because that's England on top of the Wales, Scotland and Northern Ireland. So it's my answer that's on the calculator plus 5.35 times 10 to the power 7. And it's, what do I have to do it? It's 6.37 times 10. And it's got 5 zeros, it's going to be 10 to the power 7. Okay. So the predicted value is going to be 73.3 million. So that's going to be 73 and then 3 with 5 noughts. Okay, which is actually 7.33 times 10 to the power 1, 2, 3, 4, 5, 6, 7. Okay. The predicted value in 2037 is that. So the predicted increase, I wouldn't write predicted in an exam. You keep it down a little bit. But anyway, the predicted increase is 7.33 times 10 to the 7 minus 6.37 times 10 to the 7. So 7.33 times 10 to the power of 7 minus, and I'm going to use my answer button because I know that answer's still there. And I've got that as, it's come up as, it's 9.6 times 10 to the power 1, 2, 3, 4, 5, 6. Okay, so then you want the percentage increase. So it's 6 with 5 zeros divided by what we're actually at is 637 with 5 zeros. Okay, and then times by 100. Okay, so that is the increase, that's the predicted increase. That's is baseline from 2012. So it's that much divided by that much, and I've written it in this whole numbers. We can, when we're dividing, we can cancel off noughts like this. So actually it's dividing top and bottom by 100,000. 96 divided by 637 times 100, and then it's going to be 15.0706, etc., etc. That's a percent. So it's 15% to 2 sig fig that they want there. Number 2, the scalar map 1 centimetre is 25 metres. Length of the path is 240. Work out in centimetres the length of the path on the map. Okay, so we need to see how many 25s are going into our 240, because every 25 is going to be 1 centimetre. 240 divided by 25, 1.6. Okay, 1 centimetre represents 25 metres, can be written in the form 1 to k. So 25 metres is 2,500 centimetres. So 1 centimetre is 2,500. So k is 2,500. Scale drawing now. Okay, so the scale drawing represents a park, 1 centimetre, 25 metres. The new play area must be no more than 150 from B and closer to AD than to C. And then find the region where the play area can be positioned. So the first one, when it's a distance from a single point like this, we get a compass. I can't do all this with the video, so I'll just try and explain what I'm doing as best I can. 150 metres, we have to divide it by 25 to work out the number of centimetres. 6 centimetres. So we need a compass set to 6 centimetres, which is this number divided by this number, and you put the point at B, and then we draw the arc inside the park. You can draw it outside if you like, but it's not very helpful. So 6 centimetres, I've actually got a ruler on top of this now, and it's there and there. Okay, and I've got to draw a part of a circle that connects these here. It might not be exact that, but I haven't got a compass on my toolkit with this, or I don't think I have anyway. And that's going to be 6 centimetres as well. So basically, no more than 150 metres from B. So it can't be more, so it's got to be inside there somewhere. Okay, so it's inside here. Okay, we don't want it outside here. It needs to be inside there. Right, closer to AD, which is here, than to CD. Okay, so what we need to do here is we have to bisect the angle at D. Okay, so because D is the common letter, we need to bisect the angle. And the way we do that, again, we take our compass. We use our compass, bisect angle. Take your compass and set to, I think it's more than halfway is what they say. So a good length. A compass, and you put the point in D. Okay, so as it's there, we'll put an arc there, and then we also put an arc on the 2 purple lines. So we arc on AD and we arc on CD, and this should be, it doesn't matter what this is, but they've just got to be the same, those 2 distances, so don't change your compass. And you take your compass, still set to the same amount, and you put it in this here, and you arc up there, and then you put your compass in here, and we arc there. Does that make sense? So that's step 1. Number 2, arc on AD. Number 3, arc on CD. And then you join these together. Okay, you don't rub any of these construction lines out. Construction lines and construction arcs, we need them all. Okay, now I've actually measured this, and it's actually 100 degrees is this angle here. So these two should both be 50. But you can't do it by just measuring 50 and drawing the line. You've got to show these construction arcs. Okay, so now it says construct and shade the region where the play area can be positioned. So the reason, actually I'll describe this a bit more. It needs to be closer to this one than to this one. So it means it's got to be this side of the line. Okay, because that side of the line is closer to AD. That side of the line is closer to CD. So the shaded bit is going to be all this here. We're still in purple. Oh well, it doesn't matter, does it? This is what we want. Well, no, I'm going to take this out actually, because, well, let's take some of these out. You don't need, that's what you need. You need those arcs. And then we can shade. The shaded part is this here. Because inside this shape here, whatever it's called, we're closer to AD than to CD, and we're less than 150 from B. Okay. So the second one is we bisect the angle. I have the number arc on, and then number 4, arc on the AD, arc on the point. Oh, number 4, you put the compass point in the arc on AD, and then draw another arc, draw an arc, draw an arc, and then number 5, put the compass point in the arc on CD, and then draw an arc inside the park again, and then number 6, connect the point. You know, this is easier to do than write about. The point where the last 2 arcs cross with D. So the reason I've written it out like that is because at the moment it just looks like a splat on the page, and it's at least then you can read the instructions. Right, number 3, the owner of a tourist attraction records the amount of rainfall in millimetres and the number of visitors each day. And there's the results for the days. So as you'd expect, more rainfall, although we're only going up to 5.5 millimetres, we don't know about these. But the more rainfall, the fewer the people. Less rainfall, more people. So circle the outlier. That's one that sort of seems to be bucking the trend. Number 2, the owner claims that he'd expect around 320 visitors on a day with 2 millimetres of rainfall. Does the scatter diagram support his statement? So what you have to do is we draw the line of best fit through the data. Okay. Ignoring the outlier. So you can see we've got 1, 2, 3, 4 crosses above, 4 crosses below, and it goes through 1. So that's roughly, that line represents the data. So 2 millimetres. So then you read it off. So you go from 2, you go up to the line, and it's important to show this reading off here, and then read across there. So the line of best fit is given, looks like about approximately 230 visitors on a day with 2 millimetres of rainfall. So the diagram does not support his statement. Okay, so explain why the scatter diagram should not be used to estimate the number of visitors on a day with 9 millimetres of rainfall. You can say we're only given info, only given data for days with up to 5.5 millimetres of rainfall, so we can't use this data for a day with 9 millimetres of rainfall. Okay, in fact, if you carried on the line, look, 9 would be negative, and you're not going to get a negative number of visitors. So that's something else you could say, the diagram. So it's just, yeah. B, pie chart summarises information about the visitors to the tourist attraction on a different day. Children, adults. Why can't we work out how many adults visited that day? We could measure it. We could work out the degrees for children, and we could work out the degrees for the adults. So we could do a ratio. I don't know, the children look about 100, and suppose then, or maybe a bit more than that actually. Children look about 120. No. Sorry, what am I thinking? 180. Adults look about, you could say adults look about 100 degrees. That's what I meant to say. Adults look about 100 degrees and children look about 260. So we could do a ratio but we couldn't possibly put any figures to it because we need to know how many people are represented by each degree. We need to know, if we want to work out how many adults, we need to know how many people are represented by a degree. So we need a key to work out numbers of adults or children. Okay, you need a key. So in a school, 2/3 of the students study a language. Okay, so that's the language. Study a language. So that means 1/3 doesn't. Okay, so I've gone straight, it doesn't say to do a tree diagram here. I've gone straight into it because it's either they either study a language or they don't. Or the next sentence it's telling me they study Spanish or they don't. So 1/3, they haven't got any language. Not studying a language. And then of the students who study the language, 2/5 study Spanish. So that means that 3/5 of the language. Okay, find the ratio of students who study Spanish to students who do not study Spanish. Okay, so when we go down the tree diagram, we multiply. So it's 2/3 times 2/5, so it's 4/15. Okay, so when we go down this one, it's 2/3 times 3/5, which is 6/15. That does cancel, but I'm not going to worry about that now. And the other one is 1/3 by itself, nothing to multiply with. Turn it into 15ths, 5/15. So we've actually got 4/15 study Spanish, and it's 11/15. Everybody else is 5/15, 6/15, so it's 11/15. Okay, so it's a ratio, it's 4 to 11. Because when it with fraction with a common denominator in a ratio, we can multiply through by that denominator. Right, number 5. A's got coordinates -4, 6 there. B's got coordinates 8, 3. Find the gradient of AB. So the gradient, it's the difference in y divided by the difference in x. Okay, so the y's, I'll go for a different colour for a change. 3, there's the y's. I usually do the second one, take away the first, but you can do it either way around. You get the same answer. And then the next one, 8. As long as you're consistent. 8 minus -4. Okay, so I've done the second, no, on the top, the second y, take away the first y, and on the bottom the second x, take away the first x, and look, because it's minus 4 there, I need to have minus 4, just got to put that extra minus in. So it's minus 3 over 12, so it's minus a quarter. Equation of the line AB. Well, when we've got the gradient, remember it's y equals mx plus c. So you've actually got y is minus a quarter x plus c. Any straight line can be written like this, and the m is minus a quarter. Then we need to find the c, so we substitute x is 8, y is 3, which is there, look. So to find the c, you could have substituted this point as well, but I'm avoiding the negatives. So 3 is minus a quarter times 8 plus c. So therefore 3 is minus 2 plus c. So therefore c is 5. Add 2 to each side. So root of y is minus a quarter x plus 5. Okay, point P has coordinates 0, minus 2, and it's the equation of the line parallel to AB that passes through P. So this line, if it's parallel, it's got the same gradient as before. It's the same steepness. Okay, so if we've got a line there, we can draw it, and this one is 0 across minus 2. But it's going to have the same steepness, you see, because it's parallel. So, yeah, this looks like it's not, mine don't look quite right, but anyway. Plus c, and then we've got to substitute x is 0, y is minus 2 now, because we've only got 1 point, so we have to use the one with the negative in. So minus 2 is minus a quarter times 0 plus c, so therefore c is minus 2. Root of y is minus a quarter x minus 2. Fair-sided spinner. Clara spins a spinner twice, records the product, so that's what the answer that you get when you multiply the two numbers together. So it's 1 times 1 is 1, this one is 2 times 2 is 4, this one is 4 times 3 is 12. So multiplying across, looks like 1 times all the top row. It's 1, 2, 2, 3, 4. Then we double that row, 2, 4, 4, 6, 8. Double it again, 2, 4, 4, 6, 8. Then multiply by 3, 3, 6, 6, 9, 12. Then multiply by 4, 4, 8, 8, 12, 16. Okay. Find the probability that the product is a multiple of 3. 3 times table. It's down there. It's across there. And across there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't count that 9. Don't count that one there twice. So it's 9 out of, and then it's 25 entries in there. Okay, so it's 9 out of 25. She makes a different spinner. She spins the spinner twice, records the product. Probability that the product is negative is 0.48. So we've got some negative numbers coming in. Write the numbers on the spinner so that Kira's statement is correct. Okay. So what we'll do first of all, let's set up a table. 0.48. 0.48, and there's 25 in there. That will come up as 12. Because, let me just check. I'm pretty certain it's 12. 0.48 times 25, 12. So we need 12 negative numbers. So it's 12, so we want 12 negative. So that means when we do these products, there'll be 13 positive, because we're going to have 25 again, because it's 5. There's 5 places for the numbers. So because it's quite close, not much difference, I'm going to start by doing an even. Let's do 1, minus 2, 3, minus 4. 1, minus 2, 3, minus 4. And then we'll see what happens. See what we get here, you see. 1, minus 2, 3, minus 4. And then this one's minus. You double it and change the sign. Minus 2 plus 4 minus 6 plus 8 multiplied by 3, 3 minus 6, 9 minus 12 minus 4 plus 8 minus 12 plus 16. Okay. So that is 50-50. We need it to be slanted more towards the negatives. So 50-50, we want 12 negatives. We've got 1, 2, 3, 4, 5, 6, 7, 8. So we want the next one to be, let's see what happens when if we do a positive there. We get 5 minus 10, 15 minus 20, and that would be a 5. That's 5 minus 10, 15 minus 20, that'd be 25. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. Yeah, so we have got our 12 negatives. Okay, so basically I built that all up. See, at first it is going to be 50-50 at that point if you've got half and half. And because we want, when I got to the 4x4 part, because we want one more positive than negative, well, there it's 50-50, there it's 50-50, and that bottom one, 5 times 5, that's the extra positive one in there. So let's put these in there. 1, minus 2, 3, minus 4, and 5. Okay, so it's just basically, yeah, build it up and have a think about it. Okay, complete the, oh, what happened there? I must have touched something. Oh, good, I can see where I'm up to. There we are. Complete the table for y equals x squared minus 2x. Well, they're all filled in apart from this one. So y in there is 4 squared minus 2 times 4. So it's going to be 16 minus 8. So it's going to be 8 in there. And then we plot. So the first one, x is minus 1, y is 3. So we go to minus 1 on the x first of all. And then we go up 3 for the y. So that's there. And then 0, 0. 1 minus 1, 2, 0, 3, 3, 4 and 8. Join it together with a curve. Don't join these with a ruler. The straight line, when it's y equals mx plus c, just x's, they're straight lines. But when it's got the squares in, or cubes, or any other number as a power, it will come up curved like this. Use your graph to solve. X squared minus 2x is 2. So x squared minus 2x is 2. If we look here, we need y is 2. So we go up, this is the y-axis here. So we go up to the 2. And then we read these off. Okay, because these values of x, whatever they are, they're going to give us a height of 2. And that's the y coordinate, and that's what we want, the 2 there. So for me, so we start from the 0 here, and that's minus a half. So it looks about minus 0.7. And the other one looks like about 2.7. I would say there, look, 2, 2.5, 2.6, 0.7. Okay. Number 8. The object below is made from a square-based pyramid joined to a cuboid. Okay, the base of the cuboid and the base of the pyramid are both squares of side 4. Okay, so that's 4, that's 4, that's 4, that's 4. The height of the cuboid is 8, got that there. The total height is 13, so I reckon we're going to need that as well. So that's going to be made into a 5 there, and then that one's the 8 there, because it's 8 there, 8, 8 and 5 make 13. Total mass is 158 grams. Cuboid is made from wood with density 0.67. So as soon as I read that, I write down the formula. Density equals mass divided by volume. It's one of these that you just need to remember, and it comes into science, I believe. Pyramids made from granite. Calculate the density of the granite. And there's the volume of a pyramid formula there. Right, so we've been told about the cuboid. We know all about the cuboid because we've got the density and we've got the volume. We'll be able to work out the volume because we've got all the measurements. So we can work out the mass. So then we can work out the mass of the, so let's start with the cuboid. Because we need to work out the granite, which is the pyramid. Right, so let's start with the cuboid. Okay, I'll call this density, mass over volume. I don't know if you've seen those before, quite useful. Well, there, if you get the letters in the right order. DMV. Okay. Right, anyway. So what do we know about the cuboid? It's got density 0.67. We can work out the volume. The cuboid, that's this one at the bottom. The volume is 4 times 4 times 8. So it's 16 times 8, 128. Okay, this is grams per centimetres cubed. So this is centimetres cubed. So this means that this weighs, every centimetre cubed of this wood that's made the cuboid weighs 0.67 of a gram. Okay, and so because we've got 128 centimetres cubed, we've got to do that times that. So the mass of the cuboid is going to be 128 times 0.67. I can say here, look, the mass of the cuboid is density 0.67 times volume 128 times 0.67, which is 85.76 grams. So we've got everything for the cuboid. So we're going to move on to the pyramid. The density we need to know. The volume we can work out. Volume of a pyramid, a third times the base area times the height. So it's a third. Base area is 4 times 4 again, and the height is 5. So that's going to be, I know what it is, it's 80 divided by 3, because 16 times 5 is 80 divided by 3. That's going to, that'll give us some rounding off, so I'm going to leave that one as that one is to avoid rounding errors. Got the volume. Right, the mass we can work out, because the total mass is 158, and we've got the mass of the cuboid, so it's going to be 158, so it could be 85.76. 72.24 grams. Volume, mass, and what do we want? Density. That's what we need. That's the answer. So density is mass over volume. So it's that divided by that. So density is 72.24 divided by 80 divided by 3. 72.24 divided by, and look at this in brackets, 80 divided by 3, close brackets, 2.709 grams per centimetres cubed. We've only ever been given 2 decimal places, so I'll put 2.71 to match the accuracy in the question. We've got that there. Okay. Right, triangle A is drawn on the grid. Enlarge it with scale factor of 1/3. So even though it says enlarge, because it's 1/3, it actually reduces it. And centre enlargement -1, 5. So that's our centre there. -1 across. So I'm going to draw. Right, so I start from the centre, and I'm going to draw a line to each of the corners of the triangle, like so. Okay. Now, if it was more than, if it was say 2 or even 1.5 or anything like that, then you'd have to go beyond the shape. Because it's a third, it's going to stop before the shape. So, yeah, that's why I've stopped there. If it was like more than 1, you have to stretch it out. Okay, so you don't always just stop there. Write 1/3, and basically you've got to, so you can measure, you could actually measure the length of this line and then divide it by 3, and you'll find actually that it's there. So you can measure it. I'll measure it mine with my ruler. It's actually, you could do it that way, 5 and a bit centimetres. Divide by 3 and it'll be there. But what you can do, you can say, right, it's going from there to this corner here. We go 1, 2, 3, 4, 5, 6 across and 3 up. So because it's 1/3, it's 2 across and 1 up, because that's 1/3 of 6 and that's 1/3 of 3. So the next one, it's 2, 4, 6, 8, 9 across. So 1/3 is going to be 3 across. Oops, I don't put the dot there, that's a bit too much of a definite dot. And then, so we got to there, and then up from here, 1, 2, 3, so it's going to be 1 up. Okay, or again, you could measure the line. You can see, look, they split into thirds. This way, 1/3, 2/3, 3/3. Okay, so any way you get your thirds is fine by me. And there we are. Now this one here is 2, 4, 6, so it's just going to be 2 at the drop. Once you get a few right, a few in place, then you know, this almost you can figure out where they're going to be. Okay. It looks a bit wonky, that actually. I'm not happy with that. Just get that one straightened up a bit. That looks better. Okay. Right. Prism P, prism Q are similar. The ratio of the surface area of P to the surface area of Q is 1:3. J says the height of P is 1/3 the height of Q. He is wrong. Okay. So, right, what we've got here, I'm going to write this down here. And then we're going on to volumes as well. So we're doing about heights, volumes and areas. Okay, so if you've got P to Q, okay, so we've got a length, which in this case is a height, but it could be a width, so I'll call it length for now. And then you've got area, and then you've got volume. Now, the area ratio is 1:3. Okay, when you go to the length, it's got to be a square root. Okay, so this 3 is actually, it's 1 to the square root of 3. And the volume is going to be, whoops, I'm losing it there. The volume is going to be 1 to the square root of 3 times the square root of 3 times the square root of 3. This one, you see 3 is square root of 3 times the square root of 3. So that's the one that we've been given. Okay. So to go that way, you take the square root of it. And you go this way, the volume is the square root of it cubed. Okay, so you can say the height scale factor is the square root of the area scale factor. Okay, that's why he's wrong. He said it's the same, 1:3, when it's not. Okay. Right, so the volume of Q, this one here is 86. Calculate the volume of P. Okay, so what we've actually got to do for that one, we've got to do 86. See, P is smaller. We've got to divide it by the square root of 3 times the square root of 3 times the square root of 3, which is actually 86 divided by 3 root 3. So, I'm going to, it's a calculator for this question. 86 divided by 3, square root 3. 16.6. 16.6. 16.6 centimetres cubed. That's to one decimal place. That's definitely right. I'm just a bit surprised by the answer, but it's definitely right. Right, number 10. Anna records the amount of money spent on 140 customers in her shop on a day. Draw a histogram. Okay, so this is not a straightforward bar chart. Okay, when you have a histogram, the area of the bars represents the frequency. Okay, and what we actually call it's the frequency density. Frequency density. Okay, so the areas. So we've got the widths. What the widths of the amount spent. So that's 5, 5, 5, 5. That's 10, and that's 20. Okay, so we've got the frequency. But you remember, so if we're going to draw a bar here from 0 to 5, say, okay, and it's got to have frequency 35, and it's the area that's got to be 35. You've actually got to do 35 divided by 5. So you've always got to do the number. This gives us the frequency density. And that one's 5, 5, 5, 10, 20. So that's going to be 8.4. That's going to be 4. It's going to be 3.6, 1.4, 0.55. So our highest is 8.4. 1, 2, 3, 4, 5, 6, 7, 8.4. Shall I write those down? Okay, so the first one, 0 to 5, goes up to 7. Okay, so you think 5 times 7 is 35 for that bar there. Right, so the next one, 5 to 10, goes up to 8.4, which is there. I'll draw another lines in a minute. The next one, 10 to 15 is a 4. 15 to 20 is a 3.6. 20 to 30 is a 1.4. Not 1. 20 to 30. And the next one, 30 to 50 is a 0.55. So that's 0.2, 0.4. That's 0.6, 0.5, it's there. 30 to 50. So let's draw that line all the way across there. There we are, that'll do. So use a ruler, be careful, etc., etc. We draw all these bars now. Mine comes up quite, I'm doing this without a ruler, because iPad is amazing. There we go. There's your histogram. That's an example of why it works, how it works. Right, Anna wants to offer a discount to the customers who spend the most money in her shop. So a voucher saves 10% when you spend more than something. She wants to give the discount to approximately 25% of her customers. Suggest a suitable amount of money for Anna's use on her voucher. Okay, so she's got 140 customers. So 140, 25% of 140. So it's 140 divided by 4. That's going to be 35 customers. Okay, so she's got 11. The customers, we actually want the frequency now. So she's got 25 there. So they were all going to get a discount because there's 25 of them. They've all got a discount. No, not that one. So then we've got 18 in this category. They're not all getting a discount. We want 10 of them, which is roughly half of that actually. 10, so it's just slightly more than half of them. Okay. So I would say that was about there. You can do it exactly, I did do it exactly earlier. But then when I looked on the mark scheme, they seems to be okay if you're doing it a little bit. So 10 out of 18, you actually want 10 out of 18 to find, we've got 10 out of 18. Oh, what's happening? 10 out of 18 times 5, because the width of the bar is 5. I'll just do that on the calculator. 10 divided by 18 times 5. So it's about 2.8. 2.8 from this side, which rounds off to 3, so that's fine. So, and the actual mark there is the 17. That's 2.8. So it's like £2.80 less than there. So those ones want the discount as well. I was built it up that way. So it's 10 out of 18 going that way. That would be 8 who don't get the discount. That's the 10 who do. And the cut-off point's about 17. Okay, so I would say £17. Justify 35 customers. 8 out of 18 times 5. That's going to be 2.2. Okay. 15 plus 2.2, £17.20 would be a bit more exact. So we've got 10 in there. I think it's all on the diagram. We've got 14 in there and 11 in there. Okay, £17.20. Okay, justify your decision. See yellow bars above. Right, anyway. Right, number 11. Sunil makes 7.5 litres of soup, correct to the nearest half a litre. So that means he's made between 72.5 to 7.75 litres. Okay, because if he's gone either side of them, if he's gone to 7.2, say, that's going to go down to 7. If it's gone to 7.8, that'll go to 8. So that's what he's got there. Those. It's somewhere in between there. He serves the soup in 300ml portions, correct to the nearest 10. Okay, and 24 people ordered the soup. So if it's correct to the nearest 10, it's either 295 is the portion size up to 305. So if you see, look, nearest half a litre, you go plus or minus a quarter. If it's to the nearest 10, you do plus or minus 5. Right, 24 people order the soup. Does he have enough soup? Show how he does he definitely have enough soup? So he might have, he might not. It depends how accurate his measurements have been. So worst case scenario, he's got 7.25 litres and he's given everybody 305 millilitres. So that is 7,250 millilitres divided by 305 millilitres. Oh, so that's going to be 23.8 portions. So he might not have enough. And it's only a might, because the rounding off means it could go either way. Right, number 12. Y is inversely proportional to the square of x. Okay, complete the table. So there's two things. If it's directly proportional, you'd have y equals k times x squared. If it's inversely proportional, it's y is k divided by x squared. Okay, so it's the square of x, x squared, direct, k, directly, multiplied by x squared, inversely, k divided by. And for this question, we're on this one here, inversely. Okay, so the first thing we need to do is work out the k, and they're giving you a known pair there. So y is k over x squared. So we substitute. X is 10, y is 9, and that will give us that 9 is k over 10 squared. So So therefore k is 9 times 10 squared, which is 900. Okay, so eventually we know y is 900 divided by x squared, because we found the k. So the known pair, there'll be a known pair and it will tell you the k depending whichever one you're using. Okay, so this is x is 6. If x equals 6, y is 900 divided by 6 squared, which is 36, 25. And if y is 4, so 4 is 900 divided by x squared. So therefore x squared is, well, 4x squared is 900. So x squared is going to be 225. So therefore x is 15. Okay, next one. AB are points on the circumference of a circle. Centre O. CA and CB are tangents to the circle. Okay, if you remember, tangents meet the radius at right angles. Okay, and these are both radiuses. Prove that OAC is congruent to OBC. That means that these two triangles, OAC, exactly the same to OBC. So congruent is exactly the same. The other word that comes up is similar. And that's when one's an enlargement of the other. That's similar, but that we don't need that one today. Okay, so if you remember side, 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 if we can prove all the sides are the same, then it's going to prove that the triangle's the same. Okay, so OC is a common line to both triangles. So that's fine, that's good. I have another colour for a change. Let's change my colours a bit. So we've got that line sorted out. And then OB and OR, sorry, OB and OA. OB equals OA equals the radius of the circle. So that's the same. That's the same. Hence, a second identical side. Length side. And then finally, right, this is a right angle triangle. So this would be the hypotenuse. This is one of the sides. So this here, these are going to be the same as well. We've got the same hypotenuse and the same, one of the other sides is the same, matches. Or we could do it the Pythagoras route, or you can say tangents from a point to the circumference of the circle, they're automatically the same as well. Okay, AC and CB. AC equals BC because tangents from a point to from a common point to the circumference of a circle are identical, or have, I should say, have identical length. Okay, SSS means that they're congruent. You can have, also you could do it with side angle side as well, and that would be this side, there's the angle, and that side. So two sides and an enclosed angle. If you can prove that that and that and that match that and that, and that's the same. And it is because if you wanted to do the angle, we've got the slides anyway above, but if you want to prove the angles are the same, you can say tangents make a right angle with the radius of the circle. So therefore, angle OAC is equals to angle OBC. That's if you wanted to do it that way, but either way will do. Right, number 14. Here is a function. Function a, x. We add 3 first of all, then we multiply 2, and out comes y. Complete the table of values. So there's the x. Add or multiply, it's add 3, multiply by 2. Minus 5. So what we've got to do, minus 5 plus 3 is minus 2. We do minus 2 times 2 is minus 4 in there. Okay. Let's just put that there. That's where that one comes from. So now we need to work out how to get 11. So you think of a number. We don't think of a number. We know what y is. We know the y is 11. So something has been times by 2 to make 11. So it's going to be 5.5. So we've got to do 11 divided by 2 first of all is 5.5. We've got to go backwards and do the reverse. So then we've got, so something plus 3 makes 5.5. So we've got to subtract the 3. So it's got to be 2.5. 5.5 take away 3 is 2.5 in there. Okay, so that's how we got to that one there. Here's another function. Divide by 5, add 4. Find the inverse function. Okay. Right, when you do the inverse function, you've got to start at this side. You've got to take away 4. And then that says divide by 5, so we've got to times by 5. Okay, so it's the inverse functions, and we go in the reverse order. With a function, we say we'll start with the x, and out will come the y for the inverse function. So it's x, so y is equals to x. We start here, take away 4, and then we times by 5. So you've got to put that in brackets, because everything needs to be times by 5. Okay. So take away 4, put it in brackets and multiply by 5. Otherwise it will just be x minus 4 minus 20, and that won't work. You need to do both bits of these by 5. Here's a composite function. So we do function A, and then we're going to follow up with function B, and out comes 2p plus 4. We start with m. Right, function A is up here. Function B is here. So we start with m, and we do function A first of all. M. We do function A. First of all, we do m, and then we add 3. I don't really want that there. First of all, function, let's call this A, and we do A to it. We'll do m, then we add 3, and then we multiply by 2. So again, it's all times 2. Okay, and then we've got to do function B to it. We've got to do this one. We've got to divide by 5, and then we've got to add 4. So it's m plus 3 times 2. And divide by 5, so you've got to divide all of that by 5. Then you've got to add 4. And out pops 2p plus 4. Well, we've got that, so that is our 2p plus 4. So hence 2 m plus 3 over 5 plus 4 equals 2p plus 4. And we need to find, what do we want, m in terms of p. Well, let's cancel those 4s to start off with. And we can cancel, and then, I'm going to cancel the 2's as well. So m plus 3 is 5p, so I'll multiply both sides by 5. I don't like the way I've done this, I've been too lazy. I'm rushing a bit. Right, so start again. First of all, I'll take, that means therefore, take 4 from each side. 2m plus 3 divided by 5 is 2p. Then this divide by 5, I'm going to multiply both sides by 5 to cancel out the divide by 5 on that side. So therefore 2m plus 3 is 10p. We want to end up with just an m on the left hand side. So the next thing I'm going to do is divide both sides by 2. So m plus 3 is 5p. And then I'm going to take away 3 from each side. So m is 5p minus 3. Okay. Sketch the graph of y equals sine x for x between 0 and 360. So I actually know this off by heart, that 90 degrees is 1. We haven't got the dots there, have we? Okay, 0 is 0. 180 is 0. But if you don't know it, you just need to do it on your calculator. That's all there is to it. If you don't know what it looks like, if you don't know this off by heart. Okay, but that's what they're like. But you can recalculate, make sure that it's in degrees, the mode degrees. And then you can just do sine 90, etc., sine 180 and plot them. Solve the equation 5 sine x is minus 3 for in the range 0 to 360. So we're going to have sine x, divide both sides by 5. So x is sine inverse minus 0.6. Shift sine inverse, my calculator is in degrees, minus 0.6, sine away, and it's minus 36.9 degrees. Right, so it's given me a number, minus 36.9, and I don't want negatives, I want positives, because this here needs to be between 0 and 360. Okay, but all is not lost. Okay, so minus 0.6 is here. If we complete this curve, something like that would look like. What it's given me is this solution here, minus 36.9. Okay, so there is symmetry here. Okay, and when we read off to the minus 0.6, the ones that we really want, we want that value of x. And then we want that value of x there. Now this symmetry, this 36.9, there is that distance here. These little green lines that I've done here, they're all, that's 36.9 degrees. And the length of that line is 36.9 degrees. Okay, so because it's, you can imagine going from the 0, it's from the 0, it's 36.9 as the curve goes negative. So 0, curve goes negative, 36.9 across. 0, and it's that way, 36.9 that way. Okay, so our solutions are 180 plus 36.9 degrees. And then 360 minus 36.9 degrees. So it's going to be 216.9 degrees. And then 360 minus 36.9 degrees. 323.1 degrees. Okay, simplify. Got that one. End of questions. Done well today. Simplify. I've done well. Saying well done to myself. There's a reason I'm saying that. Is because I did this once and my voice didn't record and I was absolutely gutted. Okay, so I've had to do it again, but I've speeded up a lot second time round, and it's neater as well, so it's better for you. So there we go. Simplify 3y cubed divided by y to the power minus 4. So when you divide, it's y and y, and it's powers. It's the same letter there. You subtract the bottom power. Okay, and even though it's a minus there, you've got to put minus, minus. It's always got to be subtract. And then if there's a minus there, it's minus that number. So it's going to be 3y to the power plus 7. In its simplest form, common denominator, x minus 1, x plus 2, plus x minus 1 times x plus 2. Okay, you won't need to write all this out, I'm just doing it like this because some people learn it this way, but I'll show you the quick way at the end. So this first fraction here, this has been multiplied by x plus 2 in the denominator, so multiply the numerator by x plus 2. And similarly, this one, the x plus 2 has been multiplied by x minus 1 in the denominator, so we've got to multiply the numerator by x minus 1. Okay, so then, and this is where you could have gone straight to this step if you know what you're doing. And x minus 1, x plus 2, which is that one times that one, you see, with the brackets. Okay, and then this one, you see, it's that times that, plus that times that, over that times that. I went to talk a group and they said, ooh, it's the upside down ironing board method. I didn't teach like that myself, but it always stayed with me, so maybe it will stay with you. X minus 1 times x plus 2, there. It's that one times that one, and that one times that one. So there you go, the upside down ironing board method. So we've got 3x. It's going to be 3x here plus, let's expand the brackets. 3x plus 6 plus 4x minus 4. So it's 7x plus 2, x minus 1, x plus 2. Okay, so it's 3x plus 4x is 7x, 6 minus 4 is 2, and those two multiply together. Right, number 17. Show that the cube root of 81 can be written as 3 to the, divided by 3 can be written as 3 to the power of 1/3. So the cube root of 81, so that's the cube root of 9 times 9. So it's the cube root of 3. See, I'm going for 3's because of these 3's. 3 times 3 times 3 times 3. So it's the cube root of 3 to the 4, which is actually 3, 4, 1/3. Did that quite quickly, sorry about that. So I'll just explain my thinking. 3 is in the answer. So I'm breaking down the 81 and I'm hoping for 3's, and I've got them, look, 81, 9 times 9, 3 times 3 times 3 times 3, 3 to the power 4. Okay, so that's what's going on underneath there. And the other bit is the cube root, and that stays the same. So actually I think that's alright. Now the cube root, I don't know if you've seen like a square root of x is x to the half, or the cube root of x is x to the 1/3. The fourth root of x is x to the 1/4. Get the pattern? Because that's, I'll leave that there. Okay, so because it's to the 1/3, so it's 3 to the 4, but then the cube root means we put a 3 in the denominator. So in the numerator of this one here, we've got 3 to the power 4/3 divided by 3. Now 3 is actually the same as 3 to the power 1. And the reason I've done that is because I want to use the rule that I did here. So it's going to be 4/3 minus 1 now. So it's going to be 3 to the 4/3 minus 1. And 1 is 3/3, so it's 3 to the 1/3. QED. There we are. Right, last question. Alvin has the crate in the shape of a cuboid. The crate is open at the top. The internal dimensions of the crate are 46 by 46 by 55. It's got a stick of length 95. He places the stick in the crate so that the shortest possible length extends out above the top of the crate. Calculate the length of the stick that extends out of the crate. Right, so the longest way to place this stick is from this corner, like diagonally opposite corners. That's going to take up, that's going to get most of the stick inside the crate. Okay, now this is actually Pythagoras in 3 dimensions. is what we're going to use for this. There's a right angle there, you see. So the length of the stick that extends out of the crate. So we want that bit there. Okay, so we need the diagonal. So we need to work out that bit first of all, and that's what we're going to use Pythagoras in. Feeling a highlighter coming on. Let's do that. We need that bit there, and then we can work out the other bit. So the length inside the crate is, and when you do Pythagoras in 3 dimensions, you just say it's the square root 46 squared plus 46 squared plus 55 squared. It's that squared, that squared. So Pythagoras in 2 dimensions is AB, square root of A squared plus B squared. If the right angle's there. With 3 dimensions, it's still the square root. What I'm trying to get around. Don't say it's the cube root, because it's not. It's still the square root. So square root 46 squared plus 46 squared plus 55 squared. So on the calculator, I've typed into the calculator exactly what's there using the square root button, and that comes up as 85.2 centimetres to 1 dp. So that's inside. So outside the crate, it's going to be 95 minus 85.2. 95 minus answer 9.8 centimetres is outside. Okay. Calculate the angle that the stick makes with the base of the crate, assuming it's been placed in. So we want that angle there, which is this here. That height is 55. And we've got this here, inside is 85.2. So then we've actually got, we've got this triangle now. That's 55, because that does make a right angle, and that's 85.2. Oh, it's not Pythagoras we want now, sorry, it's right angle trigonometry. We want this angle here. Call it theta. They call it theta at GCSE. Anyway, so we've got opposite, and we've got the hypotenuse. So what we've actually got is sine of the theta, because it's SOHCAHTOA. Remember that SOHCAHTOA is opposite divided by hypotenuse. Let's write that down. Okay, so theta, we use the sine inverse, 55 over 85.2. Okay, shift, sine, oh, done the wrong one there, shift, oops, third time lucky, sine inverse, 55 divided by 85.2, which is 40.2 degrees. That'll seem right, yeah. Not too big, not too small. 40.2 degrees to 1 dp. So there we go.